Welcome to the 2021 FRC Unveiling Event hosted by us, the 9/11 CyberKnights. I'm your MC number one, Andrew, and on the other side of your screen is your second MC, Liam. As many of you know, we originally started this unveiling event to sort of provide an opportunity for Washingtonian teams to come together as a community to share our preseason progress and give each other updates on our robots. However, obviously, the season this year is situated a different format, focusing on what is known as the skills, full innovation, and game design challenges. So, with that being said, without further ado, we have our first team, the 2910 FRC team Jack in the Bot, who is a 13-year veteran team, and they are from Jackson High School. And they won their skills challenge group, the Rhodium group, this year, which is very impressive. And they were our alliance partners at the 2020 events, Glacier Peak and West Valley as well. Here is their skills challenge group video.
Hello, everyone. For first updates now, I'm Tyler Rolls, and you're watching Behind the Bumpers, this fun show where we dive deeper into robots and what makes them work. And today, I'm here with team number 2910, Jack in the Bot from Mill Creek, Washington. 2910 started in 2009, but has really broken out starting in 2018 to be a Tier 1 team out of the Pacific Northwest District area. Since 2018, they have won all 7 of their district level events. They have played in, including the 2019 P&W District Championship and the 2018 World Finalists, and they even had a chance to play 2 2020 district events and won both of them. Their sword drive is fast, and it's really brought them in the spotlight, and we can't wait to see more about their 2021 robot here. Today I'm here with Vlad, Tim, and Alexa, and we're going to be covering a full breakdown of this robot, including the concept, power cell journey, their incredible chassis and swerve, and also their electronics and pneumatic systems, breaking it down all here on Behind the Bumpers. So Vlad, you guys made a new 2021 robot here. Your 2020 robot is absolutely incredible. Sad we didn't get to see it play more, but now you have a 2021 robot here. I'd love to hear about the differences and the concepts that go into this robot, and then we'll take ourselves through the power cell journey. But tell us about some of the concept of this robot.
Awesome. Okay. So with this robot, as you might see, it's very similar to what we had from last year. Without the bumpers, the robot is about 22 by 22 inches. So it's a nice
Oh, wow.
square of 22 inches. The whole robot weighs just under 80 pounds.
Thank you so much for telling us about that. I'm really excited to get really into this robot. So why don't you start us out with the intake of this robot? We'll see the power cells kind of go through during while you're talking about it. But tell us about the intake, and then we'll kind of keep going on that power cell journey.
This year, we implemented a bottom intake. So when the robot's enabled, this bottom intake automatically goes down and stays down for the whole match until the robot is disabled. And this just prevents the balls from going underneath the robot and getting stuck there. And with this bottom intake, we have these rubber isolators which bend a good amount. And if we essentially did run into a wall or another robot, it would not absolutely destroy these parts. So the bottom intake is extended using two pneumatic cylinders, one right here, and then it's mirrored one right here. And the top intake is very similar to what we had from last year. Basically, the robot intake, basically, basically intake the robot when the person presses the button, these motors start spinning these vector wheels, and the robot can drive into the balls, and the balls get vectored into the middle of the intake. And these belts right here as well help the balls go from the bottom into the intake and into the feeder.
That makes a lot of sense. So we're going to continue that power cell journey, as I mentioned, going over to Tim next, who's going to be talking about the feeder and then into the shooter as well, too. But I'm really interested to see how this power cell goes in.
So as to the feeder, so what it uses HTD 5mm belts on the top and bottom, these timing belts that go all the way across through this arc and through the whole path. So it's only driven by one Falcon, but the one Falcon uses a bunch of gears and then belts on the other side to power the whole feeder system. It uses beam brakes, which you can see we put on the intake here, so they're very consistent. These beam brakes, once they're tripped, and I'll just show you here, once they're tripped, the feeder moves the ball. And because it only moves while it's tripped, that means that once the ball's out of the way, it's just sitting in the right spot for the next ball to get picked up. Once it trips that, they're going to be just touching each other, and they're going to be nicely packed. So, and then that continues until it hits this top beam brake, which you can see it did here. And so now that the top beam brake is tripped, it knows, oh, I have 4 balls, and that means that I'm full. So even if I try to trip it now, it won't keep going because it knows if I go any farther, I'm going to be pushing it into the shooter, which we don't want.
Well, Tim, continue us through, and let's talk about the shooter on your robot. You guys have had some of the most accurate robots out there, especially with the speed where you're able to just get in position, lock in, and shoot right away. So I'm excited to hear more about how the shooter works on your robot.
All right, yeah, thank you. Starting with the main shooter wheels, we have 3 4-inch Fairlane wheels, I believe 60 durometer, driven by 2 Falcons. Here, you can see they're on a 1.5 to 1 overdrive here. So there's the top speed on the main flywheels 9,000 RPM here. And then we have 2 SDS brass flywheels that add, greater moment of inertia. And then on the other side, you can see here, we have the top 3 2.5-inch wheels that we just added that, decrease the backspin a little bit, but increase our exit velocity. So you can see this is driven by one Falcon, that it's driven independently. So you can see, well, this will spin in the opposite way. So we have this Falcon that's driving this as an independent system because it's on bearings. And so that allows us to technically fine tune how much backspin we had and kind of the ratio between the exit velocity and the backspin. And then we have a hood, which, as you can see, is driven by another Falcon. So as you can see, there's this 60-degree travel here from the bottom to the top. And this hood was inspired a bit by 254's 2020 design. We thought it was really slick.
How many different set positions do you have on this robot for shooting?
We don't actually have a specific set position. What we do is we tune the shooter at these specific intervals, every foot or so from the shooter, from the goal, where we decide that this is a good RPM and angle for the hood. So we tune carefully just by hand for the perfect shot that we want, and then we have these as set points, and then we interpolate in between these points. So it's pretty consistent that way.
Sure, makes a lot of sense on that. So we're going to be next moving over to Alexa, who's going to be talking about your chassis that you have. Love to hear more about the drive that you guys have built. Obviously, your short drives have become pretty legendary in the FIRST community. And then afterwards, we're going to be talking more about the electrical and pneumatic systems on the robot as well, too, Alexa.
We have a frame made out of 2x1 Versa frames, and we have 2 beams in the middle that hold up our feeder plates. Right here we have a shield that protects electrical and pneumatic components, and we have some adhesive foam here to keep in our breakers. At the bottom here, we have our battery that loads from the bottom. So we stick it in through here, and it's secured in with Velcro. On our robot, we have 4 SDS Mark III Swerve modules, and they're geared fast, so their free speed is about 16.2 feet per second, and they're powered by Falcons. We also have our pneumatic tanks in the bottom here, and we have our compressor and solenoids right here. So on the top side of our robot, we have our main breaker, our RSL, our PCM, and our VRM, and we also have our pneumatic gauges here. And on the other side, if we move over there, we have our radio, we have our network switch, and we have our RoboRio. On the top, we have 2 limelights. This one here targets the power port, and the one over here targets balls.
2910 Jack in the Bot, making another phenomenal machine, has really been one of the top tier teams in all of FIRST, and I'm always very excited to talk to your team, discover more about what's going on. Thanks for taking the time to speak with us and showing out this incredible machine. Good luck with all the at-home challenges, and can't wait to see what you keep coming out with for years to come. Thanks for taking the time.
All right, welcome back. Thank you to 2910 Jack in the Bot for giving us that outstanding unveiling video to just show off their robot, and then also a very in-depth description of what they have designed this year for the Skills at Home Challenge.
Kind of like Liam said, I remember the first time I watched the video, it was one of the first ones to actually come out. So it's like had a lot of hype, and it was definitely a very clean video. I really liked the angles, especially at the beginning, really showed off very well what your robot could do in skills. So moving on, Jack in the Bot has their game design video.
Attention, all citizens of First Village. This is a public warning about a catastrophic storm that threatens to take out our communication with our neighboring town of First City. We must send our special field drones to relay information to them before it is too late. Alliance operators and robots will start on their respective sides of the field. Each robot can be preloaded with 1 data disk. Once the buzzer sounds, the 1-minute 30-second teleoperated period begins. Robots race to collect data disks from various retrieval centers to return them into their data control center. Robots may insert disks into different ports of different orientations for 1 point each, with a set of 3 disks inserted into all 3 orientations, awarding a bonus 3 points. However, watch out! The storm has temporarily disabled our controls, and the drones must operate autonomously for 30 seconds while we work on reconnecting them. During this period, any points earned will be doubled, and robots can gain 5 points for returning to their data center before the storm passes. After the connection has been restored, a random radio tuning frequency will be sent to each data center. The robots will then connect cables from their data centers to their radio towers for 10 points per connection. Robots may also tune their radio towers to the provided frequency before connecting them for a bonus 5 points per connected tower. When the mission is completed, robots return to their data centers to upload the collected information for an additional 5 points. Make the connection in First Radio Relay!
That was actually a very, very solid game design challenge video. I really love the fact that Bot named their phases, and the fact that the auto actually begins the game is very intriguing. It's definitely something that teams will have to consider lining their robots up to actually begin auto.
All right, thank you to 2910 for their presentations. Next up, we have Team 4512, Otter Chaos. They started in 2013. They're in the Team Spirit Award at Glacier Peak in 2020, and they got their first blue banner for winning their Skills Challenge group, the Neo-BM group, and they're from Cascade High School. So we will also be interviewing them after their unveiling video. So if you have any questions, feel free to put them in the Twitch chat, and we will read them out. All right, welcome back. Thank you to OtterCase for that absolutely outstanding reveal video. And we have two members of 4512 to answer some questions that we have and also some questions that you guys might have in the Twitch chat. So if you have those, please be ready to ask them. We have Henry.
Hi, I'm Henry.
And we have Nolan.
Hello.
So without further ado, here's our first question. How different is your current robot from what you started with? And also, how many alterations did you actually have to make?
So,
if you made any, why did you make?
Yeah, so we had Riptide Spec 1 or Riptide 1 for our 2020 season. And then we decided with the limited time frame that we had transitioning into the 2021 where we could actually know that we could do the skills challenge, we decided to update our robot into Riptide Spec 2, which has a couple of upgrades just in the nature of, looking at the challenges, we're going to need to be able to pick up off the ground really fast and just control the ball and then vector it. So it was a matter of looking at what we can do in the limited time frame. We had some flooding issues at our building and some equipment that needed to be refurbed before we could use it. So it really limited our time frame of what we could do. So we ended up just taking our 2020 robot and making sure that it could fit the challenges well as just making our robot reliable enough to just go through these challenges as fast as possible and keep repeating them.
All right, sounds good. So with these adjustments, was your robot able to successfully run autonomous modes that you wrote for it? And if so, how difficult were they to create in an optimized way that allowed you to be successful?
Yeah, we spent the most time on autonomous paths because we thought that it would be the hardest to do, but it would have the best like payoff. So it took a while, but it wasn't actually that hard once we got down to the paths. It was just considering like how much time do we want to spend on each one? How much time do we think we can shave off? Like slightly moving waypoints, increasing like the cruise speed, acceleration, how hard we do turns and stuff. So it was just kind of a grind, but it wasn't that bad.
Okay. Next question. What was the biggest hurdle you had to overcome for your actual submission?
Definitely the timing. We had about just when we started to film, and when we started, it was the Monday of the last week, so we had till Wednesday to do all of the challenges we wanted to do, and then edit them and then submit them. And Nolan can talk about the rest of the challenges as far as auto as well as driving.
Yeah, it was just like 30 hours total of like time with the robot to like work on the challenges. So again, we spent the most time on auto, like a little bit of Saturday, Monday, and then Tuesday, and then on the last day, Wednesday, we did our hyperdrive and galactic search challenges.
Yeah, as well as any mechanical issues in there, like replacing tread that is worn down and stuff like that, which was time consuming, and definitely dug into that. So that was very challenging.
Sounds good. Bit more of a personal question for each of you, since you clearly know this robot very well. What was your favorite part of the robot?
I'm gonna say for the beak for the meme, but um, the intakes have been hard for me ever since I started designing. It's just you're dealing with compressions, you're dealing with trying to hand off to things, and this intake really kind of um, took my past years of intakes that have been really bad and really made me happy with it, because it was able to pick the balls up really fast off the ground and then vector them without putting too much pressure and causing them to become jammed. So they would just come up into the robot, vector them. We could technically vector if we had the proper elastic net. We just never got it installed because timing. We could end up intaking up to like 5 balls in the intake and then vector them within the proper time, as well as the indexer. When it got upgraded, it was quite nice. I liked that part of the robot.
I think personally, just the drivetrain was really nice this year. Like, because historically we've not had great drivetrains. I think like just not 2018. It's always been Sims, and then like 2020 we upgraded to Neos, and this year because of the challenges I was able to like make full use of the drivetrain and go vroom.
And I can touch on the drivetrain again. It's like drivetrains again were our limiting factor in 2018 and 2019. They were just a huge hit for us, and it was just like, this is not okay. Like we need to figure this out. So we took the time to create a custom shifting, a ball shifting drive base, and over the off season, and we learned a lot via that. And we did ended up doing a chain and tube, um, blue nitrile tread for the front and rear and 2021, but 2020 it was just the middle wheel was tread, as you can see in the CAD renders there. But yeah, like the drivetrain was just super solid. It made me very happy, the fact that it isn't my favorite thing because I didn't have to worry about it. The custom gearboxes were done right. We used JVN Design Calculator, and I forgot the sim for the friction and stuff we used, but we just plugged in numbers. We didn't have to do a lot of really strenuous math, and that was a really nice thing, is we were able to create a really nice drivetrain without a ton of external experience in a lot of things.
I guess it's a little blast to the past. But do you have any lessons or sort of takeaways from the 2020 robot or even season?
Nolan, you want to go first on that one?
Yeah, I think there's just a bit of a planning problem on our part. Just like through the season, we definitely were more like proactive in like prototyping and like getting to stuff sooner. But we just had a lot of like stuff that cropped up that we didn't account for, and it ended up hurting us a lot. Like when we got to our first comp, I mean, it's kind of a moot point because like everybody didn't really get to the second comps or any comps at all, but it's something we wanted to work on in the future.
Yeah, it's just a lesson learned of planning. It was our one of our better planned seasons in general, and it followed a very nice structure. But we ended up just like, whatever work you're doing, it's taking that extra time to overview it and double check anything that might crop up in the future, it saves a lot of time, which can save programming and mechanical during your competitions and all of that. So just the overview was like taking the extra time, taking the extra 15 minutes instead of moving to the next thing, making sure that whatever work you did is solidly locked in before you move on.
Next question is, obviously when building your robot, you want to make its functions as efficient as possible. How did you decide what you wanted to prioritize for the skills challenges, and where does that show most on your robot?
I would say for the skill challenges for the 2021 season, it was the intake. So we knew we needed to be able to, for the shooting challenges, be able to intake from the top because we needed to come back in the zone. You just needed to hand off the balls really quick in the intake, as well as in the galactic search, which we knew we could do really well because of a couple things. And I'll let Nolan touch on the autonomous side of that. We need to have an intake that was just up with the pace. It just needed to be able to take that ball and get it up into the robot or in the robot's control. It didn't need to exactly get it to the shooter or anything. We needed to be able to control it. So the intake was a big thing. We changed a lot of things on how it was driven. Instead of doing gears, we ended up switching it out for pneumatics because we already had pneumatics on the robot. It was like, why didn't we make that decision before? As well as we changed how we were driving it and the rollers and the mechanism so it didn't break, as well as it was very reliable.
I mean, yeah, just like you said, the intake had to be able to basically intake full width, so we could just drive it to the balls and also have it geared as fast as possible, so when we're driving the robot full speed, we don't just like ramp over the power cells.
Do you want to touch on Photon or anything? As far as
yeah, we just had we had old limelights from 2020, and we updated the software to Photon Vision, and that helped a lot just for tracking. We did the pretty standard snapshot, and then we use that to calculate which path we're running, and then we just, again, autonomous grind.
And last but not least, what was your favorite challenge or driving / auto path?
Nolan, you go first on that one. I'll have to actually think of that.
I'm not sure. Maybe bounce, because when we ran it the first time, it worked perfectly.
First time hype, yeah. Yeah, bounce was up there. Just because we were allowed, because our intake, the way it's designed with the way you actually pop the ball in and use the bumpers as a nice compression zone, we were able to pretty much max out our reach, and we were able to really utilize that to our advantage to take what is a pretty long West Coast drivetrain, which is hard to maneuver through a lot of that stuff, and we're able to utilize that to cut down our time a lot. But my favorite was still the slalom. We were able to really whip these corners really hard with our waypoints, and we were just perfectly matching those edges. It was
also the
very
first path we
satisfying.
did.
Yeah, we spent the most time on that one, to be honest.
All right. Very interesting and a lot of very good insight. Thank you guys for being willing to come on and share a lot of detail about your design process this year, and congratulations on winning your group.
Yeah, thank you.
Thank you very much for having us on, and thank you for congratulations.
So following our interview with Otter Chaos, we'll be moving on to Team Pronto.
Hi, I'm Cameron, and I'm a member of Team 3070 and Build. This year's build went faster than it does on most years. This can be partially attributed to the fact that the robot was fully catted by the time that we started building, and the only people who showed up to build were committed to making the robot. Robot concept. Initial considerations included speed, maneuverability, and complexity. Speed. All three challenges focused on having a heavy emphasis on time, and thus speed was very important to our design. Maneuverability. Both the AutoNav and hyperdrive challenges required the robot to make sharp turns and other difficult maneuvers, so having a maneuverable robot was very important to the design. Complexity. When designing our robot, we knew that we didn't want to have an overly complicated robot, so we decided to make it as simple as possible unless absolutely necessary. X-Drive drivetrain. This allowed for lots of maneuverability while not detracting much from speed. It was also far less complex than other options such as warp drive. Over-the-bumper intake is one of the most commonly used mechanisms and is not very complex, so it's perfect for our robot. Our box storage with had an inclined base. We chose to have a simple box to store power cells. This design was not very complex and prevented bottlenecks. Drivetrain. As I said before, we decided to use an X drive. This allowed us to have 3 degrees of freedom, and we used a direct drive with tough box mini gearboxes and 1 Falcon 500 per wheel. We also decided on using odometry wheel modules for accurate location tracking. This eradicated the use of complex math for programming. I'll pass it over to intake now.
All right, hello, my name is Hannah. I'm on the CAD team, and I'm going to talk about our intake. So our intake was our main moving component on our robot. And as it was said, we went with just a simple over-the-bumper design for just ease of use and making. The side plates were just made from a simple, just laser cut wood, and we added churros for just extra structure and support and just strength. The balls were mainly moved by 3 Versa rollers with belts attached to them that were powered by a bag motor, as you can see up on the top. And these Versa rollers were positioned so that it was guaranteed that a ball would be touching at least one of them at all times to ensure that the ball wouldn't get stuck or jammed anywhere on the way up. When it's resting in its upwards position at the start of trial, the compliant wheels that you see along the top will press into the top of the box. And when the robot is turned on and the wheels engage, they will roll and push off of the box to bring the intake forward and down. And now for programming.
Hi, my name is Abel. I'm a sophomore on Team 3070, and I'm in both CAD and programming. Talking about programming, or speaking of programming, to determine the trajectories our robot would take, we decided to use Pathweaver for our main trajectory generator. And as seen in the slide, one of the paths that we created for the Galactic Search Challenge is shown. For the drive system, the X-Drive drive system proved quite a difficult challenge for our programming team and for other sections of our team, for the main reason of being that we haven't ever done X-Drive and in most of the challenges that we participated in. So we had to learn how X-Drive worked, as well as learning how to program the 45-degree Omni wheels on our robot to follow the X-Drive method. And we also had to figure out effective and useful methods and ways to program X-Drive in order to perform successfully. Besides that, the movement of the robot utilized field-oriented controls, which is it was a very easy system that allowed our driver to easily manipulate the robot without much interference. And for the vision for the robot, we decided to use a Raspberry Pi encrypted vision system to locate the points and balls around the field and overall help the robot succeed in those challenges.
Hi, I'm Kaylee, and I'm on build, but I was also a part of the game design challenge. Our game was Locomotion Commotion, in which robots race to repair and load their Alliance train with cargo and return to the station before the train's departure. Robots start the match with their bumpers touching the wall anywhere within their Alliance zone and can preload up to 1 chain per Alliance or 2 cargo per robot. During autonomous, robots work to cross their Alliance's autonomous line worth 5 points, load cargo onto their train cars, and link them together for double the points they would earn in teleop. In teleop, robots will race to collect and place cargo from around the field into designated Alliance train cars. Cargo is located in various cargo depots around the field, accessible to both Alliances. Each cargo placed in the train car is worth 4 points. However, only cargo scored in a car that has been linked to the engine car will count towards the final Alliance score. Each alliance's train contains 4 cars, the first of which is the train's engine car that can be used to score points without needing to place any chains. All other cars may be connected to the engine directly or through other train cars. Placing chains earns 40 points for every linked car and opens up cargo scoring in that car. For the number of chains needed to link each car together increases from 1 to 3 as the cars get further from the engine. Chain links are located at the human player stations on the opposite alliance's driver's station and cannot be blocked by the opposing alliance. An additional ranking point can be earned by fully repairing the train, fully linking all the cars, and filling each car with at least 10 cargo pieces. At the end of the match, teams will race to climb up the train station before the train leaves. Teams can park at the base of the station in their designated alliance zone for 8 points, climb to the first rung of the station for 24 points, or climb from the first to the second rung for 40 points. An additional ranking point will be given to teams who score 88 points or higher in the endgame. Thank you to Team 4911 for hosting.
Yeah, so again, that was 3070 Team Pronto, Shorewood High School, who are one of our 3 veteran teams today, or very veteran teams today, started in 2009. And I'd just like to comment shortly on their programming slide. I thought it was very interesting. They also went over the fact that the X drive was something new, and I think that embodies really well what we should be doing, not just doing the same old, but also trying new things, figuring out what's best as each season.
All right. And for the game design challenge, the just how creative it was and the usage of chains as a game field element, I think allows for a lot of creativity and interesting gameplay if it were to be played. So thank you to Team 3070 Pronto for their submissions on their skills challenge and their game design. And we will be now transitioning into Team 2930 Sonic Squirrels. So their skills challenge video.
All videos filmed in this presentation were in fully masked company following state and school guidelines. An important part to understanding our Orange 1 robot is the progression made from the 2020 season. We start with Red 1, a fast, low shooter bot we took to our first competition. Then we moved to Blue 1, which addressed some major design improvements we wanted to make. And finally comes Orange 1, which takes the design concepts from the previous robots and optimizes them for the at-home challenge. We had a lot of success with our shooter on Red 1, so we prioritized the shooting missions, Powerport and Interstellar Accuracy. We also wanted to be able to use Red 1 to test autonomous codes, so we needed to use the same drivetrain, so we prioritized Galactic Search, as our drivetrain is fast, but not agile enough to excel in other driving challenges. By designing a robot that is a progression of Red 1, it allows us to integrate code and designs from Red 1 and Blue 1. We kept the West Coast drivetrain from Red 1 for its speed, and so we can test autonomous paths with a Red 1 robot without having this year's robot complete. In order to quickly pick up the balls in Galactic Search and Powerport, we decided to go with an over-the-bumper intake because we felt that it would be the quickest way to get the balls in our robot. In Blue 1, we worked on an indexing system with constant compression and a speed differential to keep balls from binding. We took this and removed the first half of the system and replaced it with a hopper, as we only need to hold 3 balls, and the hopper allows us to quickly drop balls in it for the Powerport challenge. In Blue 1, we provided our shooter a fully adjustable hood. That combined with our turret allows our shooter to be very accurate, which we decided we would incorporate into Orange 1 design, since accurate shooting is important for Powerport and Interstellar Accuracy. We chose an over-the-bumper intake for its reliability and speed. Our first roller is a Versa roller with silicone tubing, increasing the grip it has on the power cell, allowing it to quickly transfer off of the ground and into the intake. The second and third rollers are 3D printed rollers. When we were prototyping, we used 3D printed pulleys. We found that the pulley's Truro design allowed for a good grip, but still allowed for internal movement of the power cells. This is important because we use vectored intake rollers to center the power cell. We have a Falcon motor to make sure that we are always going faster than our drivetrain, and we have gas springs on both sides to provide a constant pressure on the power cell and the intake. And we have two solenoids to keep the intake in the up position while the challenge starts.
This is our indexo. We call it that because it is a combination of our indexing subsystem and our exoskeleton. In our Orange 1 modification, we cut out the front portion to create a mini hopper that funnels the balls into the indexer. And we also have an agitator that spins to prevent power cells from jamming. One of the main issues that we ran into with Red 1 was that power cells tended to bind when they were coming around the corner due to overcompression and power cell rotation. We decided to fix this in two ways. The first way was by creating a smooth S-shaped curve that provided more consistent compression of the power cells throughout the path. The second way was by looking at the geometry of how the power cell moved throughout the bend and calculating the required amount of speed differential between the outer belts and the pivot point in order to minimize power cell rotation. Both modifications combined makes the possibility of jamming in the indexo highly unlikely. This helps improve the reliability of the indexo as well as significantly reduce the load of the system, allowing us to speed it up. We also mocked up our indexo in plywood before beginning the full aluminum assembly. We were able to note the difficulties and the performance of the system. Then we adjusted our design to optimize things such as belt centers, gear meshes, and adjusting our structural ribs to account for new loads that we were unable to foresee. Our shooter is mounted to an Armabot 240 turret, driven from a custom SLS 3D printed gear, with a maximum rotation of about plus or minus 100 degrees. It is powered by two Falcons direct drive with a maximum RPM of about 6,000. We use two 4-inch brass flywheels to increase our shooter's moment of inertia and reduce the drop in RPMs after we shoot a ball, allowing us to shoot much faster. Last year, in Infinite Recharge, we found that our shooter motor maintenance was incredibly tedious and time-consuming. So we redesigned our shooter and created modules for the Falcons. These modules house the motor, belt, pulley, and bearing, allowing us to remove the module with 3 nuts and even replace it with a new one in a matter of seconds. We also have a custom SLS 3D printed hood that allows us to adjust our hood angle and optimize our power cell trajectories.
This year, in order to achieve an optimal trajectory for our power cells, our robot uses interpolated values to determine the RPM of our flywheel and rotations of our hood using preset distances from the goal. On our robot, we also use a limelight vision camera as well as PID values to automatically aim the turret and range the shooter RPM and hood rotations. The speed of our intake also changes based on the robot's total speed to ensure that our intake is always moving at double the speed of the robot.
We utilize beam brake sensors for indexo logic to ensure that power cells are properly staged and ready for shooting. We also use a secondary limelight to locate power cells in the Galactic Search Challenge. Along with this, we utilize odometry to correct autonomous pathing.
Some cool facts about our robot are that we have greatly expanded our fabrication capabilities in the last 2 years, and as a result, our robot has 33 unique in-house 3D printed parts and 20 unique parts machined on our new router. Our PoE and CAN bus boards are also custom circuit boards. During our prototyping and testing, we determined that 1.5 inches of compression was ideal for good control of the power cells while not over-compressing them. We then applied this standard throughout our Blue 1 and Orange 1 designs. We also implemented a new method of driving the robot using a Forza Xbox controller setup that utilized the trigger inputs. Finally, we will leave you with some awesome videos of our new robot.
Okay, welcome back. That was the robot reveal video from Team 2930 Sonic Squirrels. They started their rookie year in 2009, and they are from Glacier Peak High School with the mission statement of have fun, build fun, and be fun.
Yeah, so regarding the video we just watched, I found it really interesting how they tried to use a similar design as last year's, just so that they could reuse their code. I think it's very important for teams to sort of understand their priorities and figure out assets and the capabilities they have for each season as each one comes by, and kind of organize how they're going to approach each. So with that being said, we will move on to their second video for game design.
Welcome to the first robotics competition and the 2022 game Coral Cleanup. After a terrible storm off the shore of First Island, garbage and debris have been scattered across GP Reef. Robots are being sent to GP Reef to help with the cleanup as the severe flooding makes it too dangerous for humans to enter. Rare, delicate corals are also located there. They must be avoided to prevent disturbing the ecosystem. The garbage across the reef needs to be put into the containers for removal by ship. The first responders are on the decks of the SS Flowers to help get the garbage collected and sorted.
The goal is to collect garbage and bring it to your Alliance's bins at the side of the boat to be raised and sorted by human players. 2 members of each Alliance are part of the ship's crew. Your robot will begin against the side of the SS Flowers at the reef's surface. The game begins with a 15-second autonomous period. If your robot leaves the boat's side within the autonomous period, you get 15 points, and all garbage removal points are doubled during this time. During teleop, garbage removal scoring continues, with small spheres worth between 5 and 14 points, medium cubes worth 20 points, and large discs worth 40 points. Points are calculated as the trash's QR codes are scanned. You need to watch out for the delicate coral. If you knock one over, the other team gains 10 points. In the endgame, 1 robot on your Alliance will need to raise an anchor and up to 2 robots using the chain game element. Raising the anchor is 50 points, lifting 1 robot is 100 points, and lifting 2 is 150 points. The Alliance with the most points wins the match. See you at Coral Cleanup.
Okay, that was Team 2930's game design challenge for this year. One thing that I would like to highlight is just an interesting human player position, having it more in the middle of the field and having them interact with field elements in specific ways.
Moving on, last but not least, we have our very own team, the 4911 CyberKnights, and we will be presenting our skills challenge video.
Okay, that was the skills challenge unveiling video for our robot, Redacted. We didn't come up with a name for the 4911 CyberKnights this year. We started in 2014, and well, we will now be presenting our global innovation pitch.
And just to highlight again, we'll be having a interview with some of our team members after the video. So if you have any questions, feel free to send them in the chat.
Imagine you are sitting still at your desk, hard at work. Suddenly, you experience a shooting pain in your back. Later that day, you step on the scale and find a, let's say, awkward number. You're not alone. 8 in 10 Americans will experience back pain at some point in their life, which is often attributed to inactivity and long periods of sitting. Additionally, 45% of people report gaining weight at their desk job. Prolonged sitting can result in potential physical and mental problems, such as muscle atrophy, depression, or heart disease. Our team, the 4911 CyberKnights, created the Gimbal that combines a wobble cushion with attachable smart resistance bands. The Gimbal promotes active sitting and encourages a multitude of exercises. With the Gimbal, you can multitask by working out while working away at your desk.
Our competitors carry different types of wobble cushions and resistance bands, but unlike the Gimbal, these products don't integrate the items in one, nor do they include sensors that send information to an app. So far, we've started a website, gimbal.net, finished a CAD, and interviewed health professionals and engineers. Additionally, we are currently forming an LLC, securing our trademarks and design patent, and have a plan for funding through private parties and Kickstarter. But first, we have a few things to ask. We hope that you will spread word about our product to physical therapists. We also ask that you'll provide us with PVC manufacturing contacts. Imagine, you're working at your desk again, but you are now using the Gimbal. Unlike before, you may now receive an at-home or work exercise experience that will reduce your likelihood of back pain, muscle atrophy, obesity, and more. Thank you for your time, and remember, gym anywhere with Gimbal.
As you can see on the screen now, we have with us our very own Henry Caleb, who will be answering questions about the Global Innovation Challenge, the Skills Challenge.
All right, so for our first question is related to global innovation. What are the immediate next steps for your product?
Well, we got to do a lot of the beginning steps for essentially forming a business. And so the next steps would be to actually form that business, start raising money, start applying for a patent, and essentially just doing all the next steps to hopefully bring it to market and be able to sell it in Amazon, Walmart, places like that.
Moving on to our next question. What were the students' 2 to 3 biggest rewards or surprises from actually participating in the Global Innovation?
One thing that I was really surprised about was just how much real world experience we got. Like I got to write a business plan. I never thought I would get to do that on a robotics team because typically you just like build a robot, which is really cool and all, but it isn't quite as directly applicable to the real world. And then we also got to do stuff like, well, one thing that I really enjoyed was interviewing people. I feel like I'm a lot better at interviewing people now than before. We did over a dozen interviews, and now I'm getting better at asking questions and listening to people. And so those are a few things that I took away from the Global Innovation Challenge.
Okay, so we're now going to shift to a more general question. So what are some of the skills that your team developed doing the 2 different first challenges, the Game Design Challenge and the Global Innovation Challenge, that you don't think you would have gained otherwise?
Well, like I said before, it was a lot of very real world applicable stuff, especially on the business side. Typically in robotics, there's a ton of engineering, but this challenge, the Global Innovation Challenge, we got to focus on the business side and do like a business plan, of course. And so then, yeah, and one of the other things that I found personally really motivating was how typically, like for the skills challenge to win, there was a very clear algorithm that if you got this many points, you'd get this many points, and you could pretty easily figure out how you were going to rank. But for the Global Innovation Challenge, everything was a lot more subjective. And so in a way, that was more frustrating. We didn't know how to improve. It wasn't quite as clear. If I can do more repetitions of this movement, I'll get more points, or if I can increase the speed, I'll get a better score. It was a lot harder to figure out how to get better. And I think in the real world, oftentimes progress is more subjective. And so I think that was one of the big differences.
Moving on. Again, another general question. What made your team to decide to participate in all 3 at-home challenges?
I think that it was very useful to get other students to participate in other things, like Caleb said, like getting maybe a lot of engineering students went and did the Game Design or Global Innovation Challenge, so they got experience in other areas of robotics as well, besides just building a robot.
All right. For both of you, for what you worked on, were there any setbacks? And if so, how did you overcome them?
One of our I did the skills challenge, and one of our biggest setbacks was um, not a lot of time in the lab, and it took a bit to get in there. But we were able to then design longer, have more time to design the robot. So when we did end up being able to get into the lab and start making things, it was a fairly seamless transition, and it went quickly.
For our team, we started out by researching ADHD, and we spent weeks researching ADHD before talking to several professionals, and they said that unless you have tons of money to spend on research and development, you're not really going to be able to create a new product that will substantially improve their lives. And so to solve that, we just decided to focus more on personal problems. And so staying at home and sitting all day is one of the things affecting us a lot right now. And so that was how we got over it. We just pivoted.
So the next question is targeted more towards engineering, but what actually made you build a new robot?
I think we just decided that we could, and it was what we wanted to do, and we could also optimize that robot better for the specific skills challenges, rather than using our 2020 robot, which was bigger and had like a climber. We didn't really need that, so being able to kind of optimize a new robot for these challenges was one of the big things.
Okay, so another more engineering focused question. So how do you work on each specific subsystem, and what are your methodologies for testing them?
Well, how we did each specific one is typically in the past we have a lead that does each subsystem, but this year we had less designers. So, but there were also less things to design. So one person took each thing, and then and then in terms of testing, we didn't get to test this season, but usually we do some prototypes and figure things out.
So now we're kind of going back towards Caleb. But what new knowledge from the Global Innovation Challenge can teams actually use when building next year's robot?
This isn't a specific piece of knowledge per se, but I know one thing that our innovation team really had to focus on was doing a ton of research. We conducted well over a dozen interviews. We read through plenty of scientific papers and studies. And then we literally spent weeks just focusing on research to find the most effective way to do stuff. And I think being able to transition that over to robotics, where we'll do plenty of research, will definitely be able to help improve our robot.
All right. Our next question pertains to software. How do you review code and integrate feedback from different subteams?
Well, one thing that we do that some teams may not is as we're finishing up the CAD and finishing up the design process, we actually have a all team meeting with every person in engineering from software and design and all of that, where we go over all of the details of electrical. And so everyone just has a really firm understanding of how everything will interact and also just how everything will behave.
And last but not least, what was the biggest hurdle you had to overcome for your submission?
For the skills challenge, it was we didn't have a lot of time to practice with the robot because of the limited amount of time we had in the lab. And after we did build the robot, and then software got it, and they did a lot of they worked as much as they could, but in the end there was only so much we could do. Um, yeah, that was probably the bigger hurdle in terms of submissions.
Caleb, any thoughts?
Outside of our pivot from ADHD to a more personal issue, our biggest hurdle was typically, and this year too, we thought we thoroughly read through the manual, but it turns out we misunderstood the submission requirements. And so we spent several weeks focusing on just doing a problem and solution statement. And we really spent like dozens of hours working on it, writing it, thinking that was all we needed to do. But then we discovered a week or two before our interview that we also needed to do a bunch of prep for an interview. And so that was the biggest hurdle we had to overcome. And I was really impressed with how our small team managed to pull it off.
All right. Well, thank you for your answers to our questions and for your time. So thank you, Caleb and Henry, for your input and being willing to interview here. And I would also like to thank all of the teams that gave us unveiling videos and other things for us to help present and make this event possible.
Like Liam said, although things had to be in a different format this year, CyberKnights, we are very thankful to the 4 other teams that decided to submit things. We know that there were definitely some conflicts with some skills challenge. Scheduling was had been very difficult, but we appreciate the effort that everyone has put in to make it possible. I'd like to give a special shout out to our head coach, M, who is working behind the scenes today, as well as our other behind the scenes team members, Evan, Sid, and Jillian. All in all, thank you for watching today, and have a great rest of the day.